Good morning or afternoon, ladies and gentlemen. It's me, Mr. Stevens. Today, we're going to be doing a couple of different things. You're going to need your book, and we're going to be on page 147. We're going to be looking at the lesson 14 classwork. Okay? A lot of this has to do with graphing. Okay, so now we've taken a look at some of these equations. We've taken a look at some of them in standard form, and we're going to continue to see standard form again today with the first set of exercises. What we're going to be doing with these, though, is we're going to be taking and putting them into this graphing calculator that you can get through Desmos.com. Okay, so I want you to take a second, pause the video, open up Desmos, so that way you can be able to see and follow along what exactly I'm doing, and I'll be able to show you here a little bit more clearly in just a second. So when we go to graph some of these, I'm going to leave this exercises page up here. You won't be able to see this here after I go onto the Desmos page, but this is where we are. Again, page 147. We're going to walk through lots of these exercises just to make sure we are all on the same page of what we are doing and what we are supposed to be seeing as we continue and make our way through these lessons. Okay, so on page 147. We have a couple of questions. First one is to find at least 4 solutions to graph the linear equation 1x plus 2y equals 5. All right, and so what we're going to be doing with that is we're really given this equation here in standard form. And when we have something in standard form, we can graph it that way, or we can try and change its form in order to be graphed. Luckily with Desmos, all it does is it takes your equation as is and then graphs it for you. So when it says find at least 4 solutions, that's looking for individual points that would fall along this line that is created by this equation. This equation, you can just type in exactly how it goes. So 1x, and it'll change according to what I'm putting in here, plus 2y is equal to, now you see there's nothing there. It's waiting for a number to figure out where exactly this is going to be put in. And we're going to put 5, and it's going to give us this line right here. Okay, so we have several different points that meet here, and we're just going to look at a couple of them. So let me zoom in and zoom in a little bit more. And so we see that it crosses this line right here, this vertical line. This is the y-axis. All right, and it's important for us to remember and recognize what that is. This is our y-axis, and we can see that this line crosses that y-axis at 2.5. Okay? So normally I tell you don't worry about using points that don't give you whole values. Don't worry about using points that don't, give you something that's nice and easy to use. But we can very clearly see if you put your cursor right there on the point, it'll tell you at 0, 2.5 is a point that lands on this line. So that's going to be one of my solutions for question number 1, is 0, 2.5. Identifying where your 0 is for your x coordinate, okay? This is what creates your y-intercept, and we'll again get into that kind of stuff in the future. But when we get into our y-intercept, that's going to be very important for us in dealing with an equation that is in slope-intercept form. So 0, 2.5, that's one of them, and then you can use several of these other ones. I'm going to use this one at 1, 2. And if you just look and see exactly where it meets, it will essentially tell you what its coordinates are. So that's 1, 2. Let's see if there's another one that meets nice. That's 2.5. Here's this one. Come on. 3, 1. That'll do. And if I keep going down, it'll eventually cross at 5, 0 as well. So that will be my 4th solution to that linear equation. When you are using Desmos, it makes your life super easy when it comes to graphing linear equations. Okay, here in standard form, that's a little bit more different and it's a little bit more difficult, but luckily with this program, it'll do it automatically for you. Okay, now exercise 2, they want you to find 4 different solutions for the equation. They want you to change it just a little tiny bit. In this particular case, they want you to change that 2y to a 0y. So when you do that, look what happens to your line. Your line goes from being here at an angle to now it's just a horizontal or rather, it's just a vertical line. It is parallel to your y-axis, okay? And it's listed at x being equal to 5, okay? So when we do all of this, essentially what we're left with is we're left with 0y, so we're left with nothing for our y. We're not going to have anything. And so that's just going to leave us with 1x. And so essentially that boils down our equation to be x equals 5. When we delete all of that crap, it's still there. It's still the exact same thing. So 1x, or just potentially x, is equal to 5. I'll just leave it 1x, get rid of that. Okay? And so now it asks for 4 different solutions that will fall on this point. So you could essentially look at it anywhere. So 5, 1, 5, 2, 5, negative 1, 5, negative 2. I'll call all those solutions. Okay? And then wanted to know what is different. So very obviously your slope changes. The way that your line is created and the angle it moves at is obviously very different. So when we changed our y coefficient from a number to 0, it changed it from a line that was going at an angle to now a line that is just vertical. Okay? It's just vertical, and essentially our equation is equal to y equals 5. Now with 4 and 5, again, to add one, you just click below. It's super easy. Let's go with x equals negative 2 and see what happens with that one. Again, I'm going to put 1x just to make it, get rid of that option for a step function. Okay? And it's this line right here. It's black. I don't want it to be black. Oh well. Okay? So it's this black line right here. This is x equals negative 2. Let's put one more. 1x equals 3. And there we go. Now we have a red vertical line. So as we're doing this, we can see that anything that is given to us with a 0 for a y coefficient is going to give us an x equals equation. All right, that 0 for that coefficient essentially just ends it. It essentially zeroes out your y's, so that way you don't have anything left. All that's going to be left is a vertical line. All right, so when we have an x equals equation, that gives us a vertical line. It is perpendicular to your x-axis and parallel with your y-axis. All right, that's a little bit kind of opposite of what you might think. You might think the y's will make it parallel with the y, and the x's will make it parallel with the x's. It's the opposite. Your x, when you just have an x equation, x equals something, and you need to graph that, this is what happens. All right, so any of these points, again, would be perfectly fine. So you would go 3, 6, 3, 4, 3, 2, 3, 0, 3, anything. Your x value is always going to be 3. And then you're essentially just moving up and down vertically. Okay? So I'm going to leave these up here so that way we can compare them to our next little bit of what happens when you put 1x being equal to 0. That's just our y-axis. It just shoots straight up and down. That's our y-axis. So let's give it another shot. Question number 7 asks you to do 2x plus 1y. Where's it at? Here it is equal to 2. So it'll look something a little bit like that. And I want you to find 4 different solutions. So we can go 0, 2. There's a nice easy one. We can go 1, 0. That's a nice easy one. We can go, zoom out a little bit. Let's find another one. It's this one here. This one gives us a nice one. Negative 1, 4. Yeah, negative 1, 4. And let's keep going negative. This one is what? Nope. Negative 1.5, 5. No. Let's go this one. Negative 2, 6. Okay, 4 different solutions for this equation of 2x plus 1y equals 2. Again, pretty easy, pretty straightforward. So then the next question asks, well, what happens when we change that 2x to a 0 x will happen to our line. The same thing that happened when we made our y is 0 is going to happen when we make our x is 0, except it's a little bit opposite. Instead of now creating a vertical line, when we eliminate our x coefficient, we now have a horizontal line. This one runs parallel to our x-axis. Okay, so we have something that runs parallel to this x-axis. Actually, I might need to scoot this up a little bit. There we go. Parallel to our x-axis when we have 0x plus 1y equals 2. It essentially just puts a horizontal line here at 2. Let's see. If they wanted to look at what happens, obviously we just talked about what happens. And so when you put something like y equals -2, again we'll call it 1y, you get this one right here. This is that line down here, -2, not +2. So -2 goes along right there, y equals -2. Again, we're now moving up vertically with our y only equation. And so when we put y equals 3, moves it up here. Again, we're just moving up and down the y-axis. We're moving up and down the y-axis with our y equals. And so if we were to do something like y equals 0, that's going to be our x-axis. Again, that should make sense. X equals 0 is our y-axis, and so y equals 0 is our x-axis. Again, a little bit crossed from what you would normally think. Okay, but when it comes down to placing lines that are vertical, we do need to know how to do that. We need to obviously know how to do angled lines, but when it comes to vertical lines, we also need to be able to understand what those should look like graphed and in equation form. Okay, so when we have something like 1x equals 3, it is a vertical line. So when we have just an x in our equation, it is a vertical line. When we have just a y in our equation, it is a horizontal line. Okay, so there's 1y equals 3. I hope this makes a little bit more sense. As you go on to page 149, which is your exit ticket, you are asked to take two different linear equations that are given to you in standard form, and they give you the a, the b, and the c in part of putting those together. So it's ax plus by equals c, where a equals 0, b equals 1, c equals 1.5. I want you to essentially graph that linear equation. You can do that on here. That is what I want you to do. I want you to use Desmos to do that, and then take a screenshot and upload it to the assessments thing. In assessments, there's a little thing that allows you to click it, and you can upload a picture. That's what I want you to do. Screenshot your graph within Desmos on your screen, on your computer, and then upload that screenshot as your assignment. Okay, so you're going to have question numbers 1 and 2 to put those in. All right, so that's all I've got for you today. Hopefully that helps. Hopefully that makes sense. Any feedback or other information that might be necessary to me and helpful to me, I would be much appreciated. I will see you all later. Adios.